Okay, this is another class practice or example problem that we did. The question is, what is the maximum height the jet will coast to? So the engines flame out. The jet is basically a really big, awkward, heavy glider. I'm trying to see how high it can coast to. So when I look at this, what I'm going to do is I'm going to start with my little LOL energy diagrams. So I'll start with comparing my 2 points. One of them is going to be the lowest point because I know the height and I know the speed at the lowest point. And the second one is going to be the highest point because the question asks what's the maximum height the jet will coast to. So pick the points based on where you know V and H and where the question points you. So here's the maximum height. So when I look at it, it's going to have a certain amount of total energy. That's going to be the same. And then if I go through at the maximum height, well, by our definition, what we're calling the maximum height right now, at that point, I've lost all the kinetic energy. So that's zero. I don't draw anything there. And all I have is potential energy due to gravity. So there we go with the potential energy due to gravity. So basically, this jet just turned and kind of went straight up. Now, lowest point, the other location. Total energy is going to stay the same. That's our principle right now. And at the lowest point, well, it's moving at 250 meters per second, so it has kinetic energy. And it's not higher than the other point, so it doesn't have any potential. So we're looking at LOLs. Our questions are, is it moving at this location? Is it above the other location's height? And that tells us if we have these energies or not. And this LOL diagram can tell me the energy, or if you want, you can just skip it and go kind of right to those thought questions. So let's start this. First thing I need to do is indicate mathematically that we're using a conservation law. So I'll use the summation of the energy and be descriptive. You're only going to write it once, so take the time to do that. So sum of the energy at maximum height equals sum of the energy at the lowest height. Kind of easy. Next step, I'll write Ke plus Pe equals Ke plus Pe. This reminds everyone of what energies we are considering in this problem. And then I can go through my LOL diagram or I can kind of ask the question. So I'm going to kind of parallel and do them both. First, I would ask, at the maximum height, is it moving? And by our definition of maximum height, it's not moving. And by the LOL diagram down here where it says kinetic energy, there's nothing drawn there. So both those indicate there's no kinetic energy. Next, I would ask, is it above the other location at the maximum height? Yes, and I showed that on the diagram, and I showed that, of course, my answer to my question is yes. So I'm going to keep the PE in my equation. Now on the other side, the lowest point, I'll ask the questions, does it have kinetic energy? And let's see, I forgot, that's going to keep it. Does it have kinetic energy? Yes, because I drew that on my LOL diagram. And is it above the lowest point? No, it actually is the lowest point. So potential energy, I don't have anything on the diagram. And because it's not above the lowest point, then I'll mark it out. So now I have mgh equals 1 half mv squared, putting in my energy equations for those two expressions. And in this case, the mass divides out because there's m in every expression, so there goes the mass. So GH is equal to 1 half V squared. Now isolate H, the variable I'm looking for. So H is equal to V squared over 2G. Put in my numbers and units, and then I'll solve it, and then I'll take a look at my sig figs. So if you did this problem before we actually got through it, let's check your work. These are the kinds of things I'm looking for to get full credit. I'm looking for the statement at the top with the summations. Don't have it, don't get credit for it. I'm looking to know what energies you're considering, and right now it's kind of simple. Kinetic plus potential equals kinetic plus potential. And that potential energy due to gravity. There are many potentials as we kind of described in the beginning. So mgh is equal to 1 half mv squared. I'm looking for that expression with the equations. I'm looking in this particular problem that you can do a little bit of math, dividing out the mass, and that you're isolating h, putting in numbers, putting in units into my equation, and then solving it. Of course, getting the right answer and showing me the right units.